But let's get this started. All right, I'm going to share my screen with you. And here we go. So, Jolly, I don't know whose name is Jolly, but somebody's name is Jolly. And she's playing cards with her friend. When she draws a card from a pack of 30 cards, numbered 1 to 30. All right? And when they say a square, they mean a perfect square. So, perfect squares are numbers like 1 times 1. Hold on, let me do this in red. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. So there's 5 perfect squares within the first 30 numbers. So my probability of picking a square number, a perfect square, is 5 out of 30. Good.
Mister.
Yeah.
What did you get 4, 9, 16, 25?
Oh,
can you explain that? Re-explain that again?
Yes. So any number that's a number times itself is called a perfect square. So 1 times 1 is the first number. 2 times 2 is 4. Right? 3 times 3 is 9. So 9 is a perfect square because it's 3 times itself. 4 times 4 gave me the 16, and 5 times 5 gave me the 25. And 6 times 6, 36 would be the next one, but it's bigger than 30. Am I explaining that well enough, or still not enough?
Yeah, I get it now. I get it now.
Okay, good. And by the way, what can we reduce 5 over 30 to?
7?
Well, what can I divide? What's a number I can divide into 5 and I can divide into 30? In other words, what number can I divide 5 and 30 by?
Could it be lower than 5?
Well, all right. So what's the only number I can divide 5 by other than 1? I can divide 5 by 5, right?
Mm-hmm.
So if I divide the top of the fraction by 5, I get 1. And if I divide the bottom number by 5, I get 6. All right. So 5 over 30 is not wrong, but the reduced probability is 1 out of 6. All right. Tomorrow, I'll tell you what. I'll give you guys a link to a fraction website where you can reduce fractions automatically. All right. All right. Number 2. So if you leave it 5 over 30, no problem today. But if you see an opportunity to reduce, go ahead and reduce. Each of the letters in the word apple is on a separate card, face down on the table. So how many cards do we have? If we have each of those letters on a card, face down on the table, how many cards do we have? All right, so maybe I'm not explaining this well enough. Hold on.
Can you repeat that?
Yeah. So we've got each of the letters in the word apple is on a separate card, and they're face down on the table. So how many cards would there be? All right.
There'll be 5 cards?
That's right. So, yeah, so there's a card with each letter on it, basically. There's a card with an A on it, a card with a P, a card with a P. So there's 5 letters, 5 cards because there's 5 letters. And if these are all face down, we can't see what letter is on the card. What's the probability I'm going to pick an A or an L?
Repeat that again?
Yeah. So what's the probability if I pick one of these cards, I'm going to get an A or an L?
You're most likely gonna get a L.
Well, so I want to get an A or an L. So how many of those cards are either an A or an L?
2.
Right. This one and this one. So I've got a 2 out of 5 chance. My probability of getting an A or an L is 2 out of 5. Are we comfortable with that or no?
Yeah, you can keep going.
Okay. All right. So, all right. A magician showed a magic trick where he picked one card from a standard deck. What's the probability that the card will be a black queen card? And for those of you that are not familiar with a deck of cards, I've got a picture of a deck of cards here. You've got ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. The ones with the J are called jacks. The ones with the Q are called queens. The one with the K are called kings. How many black queens do you see?
2.
2. That's right. So this is a black queen and this is a black queen. And altogether there are 52 cards in a deck of cards. Count them if you want to. So my probability of picking a black queen card is 2 out of 52. And it's okay to leave it like that. I'm going to divide the top and the bottom of the fraction by 2. 1 out of 26 is the same thing as 2 out of 52. Lizzie Bet, you understanding that okay? How about you, Dio? You understanding this okay or no? It's important for you guys to let me know if I'm not explaining it well enough. I'm going to go on. I'm not hearing any questions. A bag contains 5 red marbles, 15 black marbles, and 10 white marbles. So first of all, let's count them all up. I've got 5 red, I got 15 black, and 10 white. If I add that up, I get 30 marbles. Right? Now I want to know what's the probability if I pick one of the marbles without looking, what's the probability I'm going to get red or white? Well, I'm looking for red or white, so that's 15 out of 30 marbles. Does this make sense? Or no?
It makes sense.
Okay. How you doing on this, Anastasia? You doing okay with this?
Yes.
Okay, good. 15 out of 30, which is the same as 1 out of every 2, half of them. If I divide top and bottom by 15, I get 1/2. You don't have to reduce your fractions today, but if you see an opportunity to reduce, please go ahead and do it.
So, Mister.
Yeah.
So for you to reduce the fraction, you basically did 15 times 15 and 15 times 30.
Well, you have to be able to divide both numbers by the same thing. So 15 divided by 15 is 1. 30 divided by 15 is 2. So I divided both numbers by 15. All right, so if I'm not being clear, 15 divided by 30. I divided the top by 15 and divided the bottom by 15. 15 divided by 15, 30 divided by 15. All right. If you're comfortable with that, go ahead and do that today. If you're not comfortable with that, let's worry about that tomorrow, okay?
Is the work already posted?
Not yet. We have a few more examples, and I'm going to post the work, and you're on your own.
All right.
All right. You ask a friend to think of a number from 2 to 11. So first of all, how many numbers are there if you list all the numbers from 2 to 11? Most people are going to say 9. But if you think about it, it's not 9. It's actually 10. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because you're counting the 2. All right, so if I think of a number from 2 to 11, what's the probability that we'll pick 5? How many 5s are there?
1.
There's just 1, and there's 10 numbers, so you have a 1 out of 10 probability of picking a 5. All right, let's move on. All right, each of the letters in the word opportunities are on a separate card face down on the table. So we want to know how many letters we have, how many cards. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 letters. And I want to know what's the probability of picking an O or an I. There's 1, 2, 3, 4 of those 13 that are an O or an I. So I've got a 4 out of 13 chance. Are we okay with this idea? If I'm explaining these too quickly, please speak up. All right, I roll a 6-sided die. What's the probability that the value of the roll will be 6? This is something we did yesterday. What's my probability? Anastasia, what's my probability of rolling a 6?
Your probability?
Yeah, what's the probability if I roll a dice that I'll get a 6?
I don't. A 1 out of 6?
1 out of 6, that's right, because there's 1 6, and there's 6 possible things that I could get. All right, almost done here. A bag contains 6 purple sticks, 2 orange, and 4 black sticks. 6 purple, 2 orange, and 4 black. So let's add them all up. That's 12 sticks. I asked my friend to pick one without looking. What's the probability that we're going to get a purple? Well, there's 6 out of 12, right?
Sorry, I'm late, Mr. Sheehan.
That's all right. Glad you're here. So 6 out of 12, and we could reduce that to 1/2. All right, and last problem. Am I going too fast for anybody?
No.
All right. All right, the first 30 negative integers. All right, so first of all, I'm talking about the numbers -1, -2, -3, -4, ... all the way up to -30. So there's 30 numbers. From 1 to 30, that's 30 numbers. Okay. What's the probability the integer chosen will be divisible by 5? So the numbers that are divisible by 5 that are negative would be -5, -10, -15, -20, -25, and -30. All right, there's 6 numbers that I can divide by 5 without getting a decimal out of 30 numbers altogether. So my probability is going to be 6 out of 30. And if I divide the top number and the bottom number by 6, that's the same fraction as 1 out of 5. But again, you don't have to reduce today, but please do it if you see an opportunity to. All right. Give me 1 second here. I'll stop my screen share. I'll show you something, and then you're good to go on your own if you'd like to.
Do we have any work for now?
What's that?
Do we have any work for now?
Yeah, let me show you. Yeah, let me show you what I want you to do, and then if you're comfortable, you can log off of Zoom and work on it on your own speed, or you can stay and get some help. So, if you go to Tuesday classwork and click on it, you'll see you're going to click View Assignment. I don't have to, but if you look on the Day 2 examples, you'll see all the problems that we just went through. All right, so there they all are with all the answers. All right, so if it helps you to look at those, you can look at them, but you don't have to do anything with that. The Day 2 classwork is what I want you to work on today. And then here's your homework. It's the same exact thing, just different situations, different numbers.
All right, thank you.
All right. And I will post the video on our YouTube playlist if anybody's interested in watching that. But if you're good, you can log off of Zoom. If you would like to stick around, I will be happy to help you out with your classwork.
Mr. Sheen,
Yes.
did you see how they shut down Boston?
What do you mean?